Hello everyone and welcome to the very premiere of Experiments with Big Brothers Big Sisters. Today we're doing electricity. Yes, well, static electricity and a battery, but it should be pretty cool. I got pretty excited about some of these, so I think you will too. Let's get started. Our first experiment brings me to our bathroom because there are two components, a comb and a sink. So before we get started, I need to explain kind of how all life is made up of this thing called matter. Yes, matter. So my skin, this comb, my tap, it's all made of matter. And all matter is made out of atoms. Atoms are more than microscopic particles, and they're made up of things called protons and electrons. Now, not that any of this really makes sense on a literal level, but protons hold a positive charge and electrons hold a negative charge. Now, you may notice that we're playing with electricity, and electron sounds a lot like electricity. Electrons play a very important role in generating electricity, and that's how we do it, is by harnessing the magical invisible particles of atoms. Now, with static electricity, you must understand that every atom is balanced between positive and negative particles. Those are the electrons and the protons. However, when I take something like this comb and I run it through my hair, what happens is that some of the electrons on the comb come off of the comb and go into my hair. Now this is no longer made of balanced atoms because some of the electrons left, but the protons are still there. What this means is very strange things are going to happen, from this comb bending water to lightning striking in the sky. So let's see what this static electricity can do. So first you're going to want to check yourself out in the mirror, and you're going to want to take your comb and again run it through your hair. Now you guys have felt static electricity before, I'm sure. If you're walking on a carpet with socks on and you touch a doorknob, well, all of those electrons that you've given to the carpet by walking on it, when you touch the doorknob, nature is sending protons through you to the carpet to balance that matter, to balance those atoms so that the electrons and protons are balanced. So when I give this comb static electricity by combing my hair, when I'm imbalancing its atoms, there is now a charge, an invisible force to this comb. And if you've got a comb and a sink in front of you, that's what you've got to behold. Now, it might be a little hard to see, but give it your best shot and try to touch as little as possible after you've combed your hair, okay? Let's see. Oh, I sense some movement. I don't know if you guys saw that or not. Trying at a lighter stream this time. And you can see the water moving. Now that's because, since they have opposite charges, they sort of attract each other and want to balance each other out. And you'll notice, as soon as I touch the water, there's no more bending. We've balanced our atoms, so to speak. Okay, the water one might have been a little lame, but this one really got me pumped. So again, we've got a comb. What you're gonna need is a plate, some salt, and some pepper, okay? Now again, kind of check yourself out. Oh yeah, I'm looking pretty good, going out on the town tonight, okay? All right, and then you got your plate, and in it you've mixed salt and pepper, perfect for mashed potatoes. Now that you've charged your comb, I ask you, put your comb over the salt and pepper and watch what happens. You might have to try a few times to get the right charge, but what should happen is I've probably got salt and pepper in my hair now. The pepper should separate itself from the salt and hop up into the comb. Here we are at last, at our last actual electricity experiment. This is the coolest one, I promise. Now this one is a lot more complicated and should be at least somewhat cooler, maybe more successful. What we'll need for this one is you're going to need three double-ended wires with these alligator clips on them. Okay, make sure that this rubber stays over the metal part, because then you won't get any shocks. You know, there's no real risk to you with this battery, but just in case, you know, exercise some caution. You're gonna need 3 of these, okay? You're also going to need a 9-volt battery, okay? Going to need some LED lights. So I've got one here. I've got this one here, they're very small. And you're going to need some water and 2 vessels to put it in, one of which will have some salt in it. So what we're doing with this experiment is we're going to be creating a circuit with our battery and our light so that the light lights up. Well, that's easy enough. We can just use, I think even just one set of wires, a light bulb and the 9-volt. But we're going to see how electricity travels through water. Not only how it travels through water, but how it travels better through salt water. Because salt, the way it interacts with electrons and protons, makes it so that it's a conductor. It's more conducive to electricity. Electricity passes through it very easily. So let's check it out. So here's some basics first. So we're going to take our battery, and as you can see with our battery, there is a negative and a positive end. Now, just a good life tip to know, maybe you'll need to boost a car at some point or whatnot, but the black goes onto the negative end, and the red goes onto the positive end. If you can see that here. So we've got red on positive, black on negative, okay? Now, we have electricity is trying to run through these wires, but there's nothing connecting it to make it a closed circuit. So electricity is not running through it, so it just stops when it ends up here. But if we have an LED light, which I have several around here, this is a new one. When we connect these to the prongs of the LED light, I'll show you. I've pulled out the prongs here. Okay, when we connect these alligator clips to the prongs of this LED, it should close the circuit and the LED should light up. Now, one word of caution is a 9-volt battery is pretty powerful, and I've run through about 10 LEDs having blown them, just because it's more electricity than they can handle. So if you are at the point where you've blown most of your LEDs doing this, I recommend, if you have them, taking 2 AA batteries, and I'll show you how it works after, but you can use these as a replacement for the 9-volt, okay? But anyway, so let's see how this looks. It might blow, and that's okay, but we are closing the circuit now. See that? It's a red light. So we got the red going through, that's our closed circuit there, okay? So that's pretty cool. We have powered a light using our own 2 hands and a few tools. But now, that's easy enough, right? That's easy enough. We've got these wires, but now we're going to introduce water into the mix, okay? So this is regular tap water. So if you have bottled water, it is free of any sort of extra minerals in there. It's just purified water, and that will actually not conduct electricity. But regular tap water has some minerals in it, and it's actually good for you. I mean, depends where you live, but anyway, we're going to need to introduce another wire now. And what we're going to do is clip it on here. So we're going to take our negative end, okay? So we've got our negative running from here to here, and we're going to put it onto our Where? And that is in the water now, okay? Now, we've got our light, okay? We're going to connect our positive wire. We got our positive one coming here. We're going to attach it to one of the prongs there, okay? Now we're going to introduce our third wire, much like I said. And we're going to put this one onto the side and into the water. Okay, so now, if you'll notice, we've got wire running here into the water, from the water running here, and we've got a wire running here onto the light, and this one connecting the water. We're going to hope to make a closed circuit and light the light bulb up using water as a sort of conductor, just like another wire. Okay, are you ready? Let's see if it works. Ah, it doesn't work. That's odd. Now, what makes me think that there's a problem is that that maybe we have already blown that fuse. Let's see about this one. Let's see if we've blown this one. I've got another LED here. This one, we'll see. Does this one work? Aha! I don't know if you can, how well you can see that, but this LED is still working, and as you can see, our water circuit is conducive to that. Here, I'll turn off my light. Oh goodness. Pulling my battery. And you can see very well. But how about this? So that's our tap water. Let's test with our salt water. Okay. And let's check it out. How vibrant will this one be? Oh, that is way more powerful. So as you can see, our salt water is much more conducive to electricity than our tap water is. Isn't that wild? And I encourage you to take some bottled water and test it with that and see how it hardly, if at all, will conduct any electricity. Let's take a look in the dark here. Oh, yes. Yes, look at that. One little LED, so vibrant. I love it. Look at that. Wow. Okay. Now, in case you run into a problem where you've blown a few LEDs, I blew one here already, and you don't want to waste any more just in case, you can, again, use some AA's. It's just a little more awkward, okay? Okay, so you need to make sure that the right ends, just that they're touching, I guess. So make sure your batteries are touching and that you've got a positive end and a negative end. Okay, so those are touching. Where's our LED? Where did I put them? There you are. So we've got you here. Connecting again. Okay. This one here. And then you just have to make sure that these alligator clips, they can't actually clip onto anything, but you have to just make sure they're touching. Okay, this is the final connection. Let's see if the AA's work. Now, sometimes what I've had to do is connect that and then touch this. Oh, did you see that? You see that? Yeah, look at that. That is awesome. And you can see it's a lot less vibrant. And part of that is because we're only running 3 volts through instead of 9. Let's check it out in the dark. Looking pretty good. Looking pretty good. That has been our experiment with a battery, some alligator clips, and some water. And as you can see, depending on the makeup of the water, more or less electricity is run through. Now, this is just the beginning of what you can learn about electricity. There's all sorts of amazing, wonderful ways that it's worked, ways that it is manipulated. And I totally encourage you guys to keep playing around with it. I had a lot of fun. I think I'm going to buy like a switchboard or something just to have fun with it. Thank you guys so much for joining. I know visually some of these aren't that exciting, but you know, try them at home and I think you'll have a really fun time. Also, later on this month, January 27th, Wednesday, we have an escape room running virtually, open to families, open to kids aged 5 to whatever age. And we encourage you to sign up as a group or as a family, or you can be paired with others, or you can play by yourself, whatever you want. But Wednesday, January 27th, 6 to 8 p.m., 30-minute time slots therein. I'll be running it. I would love to see you there. If you want to sign up, message us on Facebook. You can text this number, or you can email this email. Thank you guys so much for watching. Take care and have fun. See ya.